Cool, cool. Awesome. Spring break is next week. Are you excited? Yeah, this is week 8. We have made it halfway across the semester. That means next week there is no class. I used LastPass for a bit. I have been very happy with Bitwarden. Yeah, I heard the news that LastPass was going one or the other. Yeah, LastPass is one of them. I like Bitwarden because it's open source. There are a bunch of others. You don't have to go with LastPass. It's just one option of many. Yeah, I've been happy with Bitwarden. Okay. Well, it's 5:30. So I think it's about time that we just get rolling. Right. Welcome to week number 8. After this, we are halfway across the semester. Next week, there will not be class because it is spring break. So let's jump right into the slides we have today. This will complete the second section or the second module. So after this, what's due is another skill submission. This section is the modern data warehouse. And to start us off, there is a video that they have provided. So I'm going to hit that next slide, but I'm going to scroll down to this and play this video.
The data from relational and non-relational services is retrieved and formatted by using Azure Data Factory. This process is known as ingestion. The formatted data is written to Azure Data Lake Storage. Azure Data Lake Storage enables you to store large volumes of data quickly and easily prior to analyzing it. At this point, the data can proceed down 2 paths. The data is converted into a normalized format suitable for analysis and stored using Azure Synapse services. Alternatively, you can use Azure Databricks to perform other forms of data preparation. For example, you might need to perform additional data transformations or cleaning to remove anomalies and generally tidy up the dataset. You can store the cleansed data using Azure Synapse Analytics if required. Azure Synapse Services acts as a hub holding clean business data. You can perform a detailed analysis of the analytics data using Azure Analysis Services. Azure Analysis Services enables you to dig deeply into the data and generate insights from the information it contains. Microsoft Power BI can take this information and use it to generate graphs, charts, and reports. Power BI can also run ad hoc queries against the data processed by Azure Databricks.
Cool. Azure Data Factory. It's described as the data integration service. Its purpose is to retrieve data from one or more sources and convert it into a format that you can process. Get it? Factory? Ha 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 ha. Since data sources can present data in many different ways and also have noise, factory is the process to get the data the way you want it and get out any noise that's not necessary. You can define work in pipeline operations, kind of like Scratch. At least that's what it reminds me of. The pipeline can run continuously as data is received from various data sources. You can create pipelines using the GUI format or by writing your own code. Lake storage is a repository for large quantities of raw data. Since it is still raw and unprocessed, it's very fast to load and update, but the data doesn't have a structure for analysis. Think of the lake storage as like a staging point before it's turned into what you need. The lake storage combines hierarchical directory structure and file system semantics. It's an extension of Azure Blob, organized as a near infinite file system. So your files into directories and subdirectories will be improved since blob storage can only mimic a directory structure. Data Lake Storage supports portable operating system interface, or POSIX, files and directory permissions for granular RBAC. Lake Storage is compatible with Hadoop file system as well. In a warehouse solution, data is typically loaded into the Lake Storage before being processed into a structure that enables efficient analysis like the synapse. Azure Databricks is a Spark environment, an Apache Spark environment running on Azure that provides big data processing, streaming, and machine learning. It's highly efficient to consume and process large quantities of data very quickly. It has a number of libraries that can do things like SQL stuff to the data. It gives you a GUI and can test your processing step by step before doing it in batch tasks. Databricks scripts can be made with languages like R, Python, and Scala. You can create all kinds of stuff with this. It supports structured processing as well. Synapse, who was mentioned in the video, is an analytics engine. It is also designed to process large amounts of data very quickly. You can ingest all kinds of things like flat files, data lake, or other database management systems and transform them into a format suitable for analytics processing. Since doing this kind of stuff does take a considerable amount of resources, this is all made efficient for this. It uses massively parallel processing architecture. It'll have a control node, who's the brain of the architecture. It's the front end that interacts with applications. And it'll have a compute node that does all the computations. this can be distributed evenly among as many nodes as exist. Here's an example of one working in a SQL pool. So queries would be submitted in the form of transact SQL statements, and the Synapse would run them. Compared to SQL Server Database Engine, it'll receive data from a wide variety of sources. It can use also Spark Pool for Spark clusters. Within Synapse, there's a number of services that handle all kinds of things. For example, analytics can be used for things like high volumes of data, complex queries, data mining, exploration. It can also handle small volumes of data of a few terabytes, multiple sources, and whatnot. Azure HD Insight is big data processing service that provides the platform for technologies like Spark in an Azure environment. It's a cluster model, distributing processes across a set of computers. Similar to Synapse Analytics, except the nodes are running the Spark processing engine instead of SQL. And it works with all kinds of other tools together to manage your data. The next section, 4, is some of the data ingestion. Again, data can be ingested using the data factory, since that is what it's designed to do. Can work on-premise and in the cloud. It'll clean, transform, and restructure the data before loading it into a repository like a warehouse. Once it's in the warehouse, then it can be analyzed. You'll have a lot of interconnected systems to complete end-to-end for data engineers. You can load static and streaming data. It has an orchestration engine for directing and controlling other services and connecting them together. Data Factory has a manner in moving data from source to destination. Services will need to be linked in order for this to be able to occur. For example, you can connect a blob storage and link it to a storage account to Data Factory, or the SQL database link service to the actual SQL database. With that information together, then it's able to read and process data. Here is a picture of connecting a SQL database to the factory. A pipeline is a logical grouping of activities that together perform a task. The activities in a pipeline define actions to perform on your data. For example, you might want to copy an activity, or we want to use a copy activity to transform data from a source data set to destination. You could include activities that transform the data as it's being transferred, or combine multiple sources together. The pipelines don't have to be linear, like the one shown above. You can include logic activities that repeatedly perform a series of tasks, while some conditions is true, or using like a for each activity. Sometimes when ingesting data, you're bringing data that could have different column names and different data types. So there is a way to fix that if needed. You can run pipelines manually or arrange them to run as a trigger as well, to do things that at a planned schedule, or when a file arrives to data lake storage or something was deleted. Polybase is a feature of SQL Server and the Synapse analytics that enables you to run transact SQL queries that read data from external sources. They'll appear like tables in a SQL database. Using Polybase, we can read data managed by other services, as well as Cosmos, Database, Oracle, Teradata, and MongoDB. SQL Server Integration Services is a platform for building enterprise-level data integration and transformation services. It can do all kinds of things like copying and downloading files, loading data warehouses, cleaning and mining data, managing database objects, and the data itself. It is part of SQL Server. They can extract and transform data from all kinds of things like XML, flat files, relational sources, and load them into one or more places. You can use the GUI like shown here without writing any code. It is an on-prem utility, but it does allow you to run existing packages as part of a pipeline in the cloud. Section number 3, explore data storage and processing in Azure. So the Synapse analytics, the generalized analytics service, like I said, can do the transact SQL and Spark. It uses that clustered architecture with the control node and the compute nodes who do all the work. We have those Databricks that work with Apache Spark, meant to be one-click setups, stream-like workflows, and interactive workspaces for data scientists, data engineers, and business analysts. As I said, they're able to handle all kinds of storage. And something I didn't mention is you can write Databricks applications using something called a notebook. A notebook contains a series of steps called cells, each of which contains a block of code. For example, one cell might contain the code that connects to a data source. The next cell reads the data from that source and converts it into a model in memory. The next cell can plot a graph, and the final cell can save the data from the in-memory model to a repository. HD Insight, the managed analytics service in the cloud based on Hadoop, the open source tools and utilities. It basically uses a simple framework to split tasks over a large data set into smaller tasks. This can handle code in Java, and then you can submit it to into the cluster. Just like the other Spark jobs can run parallel, same with HD Insight. Hive, which you see over here, provides interactive SQL-like facilities for querying, aggregating, and summarizing data. Kafka is a clustered streaming service that can ingest data in real time. Storm is a scalable, fault-tolerant platform for running real-time data processing applications. Storm can process high volumes of streaming data using comparatively modest computational resources. It can also write to all kinds of other data stores. And you can write applications provided with the API from Apache. And of course, our wonderful data factory, which could be the beginning of taking that raw organized data and putting it where it belongs, or at least putting it in a framework that we can use. The components of Synapse Analytics are the SQL pool, the Spark pool, the Synapse pipeline, the Synapse links, and Synapse Studio. The SQL pool is a collection of servers that run Transact SQL, like the ones that connect to Microsoft SQL. The Spark pool will do all the Apache Spark stuff. You write your data processing logic using Python, Scala, SQL, or C#. It also supports machine learning with Spark ML and Azure ML. Synapse pipeline is a logical grouping of activities that together perform a task. The activities in the pipeline define the actions to perform on your data. Synapse Link is the component that allows you to connect to Cosmos database with near real-time analytics. And Synapse Studio is the web user interface that enables engineers to access all of the tools. So here's a little deeper look at the SQL pool. The control and compute nodes in the cluster will run a version of SQL database. You'll define your logic using the Transact SQL statements. Data can be split into chunks called distributions. The distribution is a basic unit of storage and processing for parallel queries that run on distributed data. The control and compute nodes use the data movement service to move data across nodes as necessary to run queries in parallel and return accurate results. And as mentioned before, Synapse will use the Polybase to make external data look like SQL tables. By default, an on-demand SQL pool is created in each Azure Synapse workspace. You can then provision additional pools on demand or provision. They're designed to run over massive data sets. You can manually scale the SQL pool up to 60 nodes. You can also pause the SQL pool if you don't require it for a while. That'll release the resources associated with that pool. You won't be charged until you resume the pool, but you can't run any queries until it's resumed. And because this is so intensive, it'll take a couple minutes to get started up again. Again, the pipeline can be either linear or it can have multiple roads. You can have up to 90 sources from like flat files, databases, or online services to put together into a pipeline with activities. Because there's no picture for Link. That's why. Synapse Link is the cloud-native hybrid transactional and analytical processing capability for Azure Cosmos that could do things like supply chain analytics and forecasting, operational reporting, batch data integration and orchestration, real-time personalization, and even IoT maintenance. Synapse Studio, shown here, is the web interface where you can make those pools and pipelines interactively. That's where you can develop, test, and debug any Spark notebooks and Transact SQL jobs. You can monitor the performance of operations that are working and manage the serverless or the provision services. All of that we've talked about is available right through here. Lastly, we have this interesting thing called Power BI, a collection of software services, apps, and connectors that work together to turn unrelated sources of data into coherent, visually immersive, and interactive insights. From Excel workbooks to cloud-based on-prem data warehouses, Power BI can connect them all. It's supposed to be simple and fast to create quick insights for everything from an Excel workbook to a local database. It's also robust for enterprise level. Power BI consists of a Windows desktop application called Power BI Desktop, an online SaaS called the Power BI Service, and a mobile BI apps for any device with native apps for Windows, iOS, and Android. These three elements together are designed to let people create, share, consume business insights in a way that serves them. Power BI might depend on how you use it. Everybody has their way of using it. It is versatile to meet different needs. It's not just accessible to anybody. You do have to create an account at app.powerbi.com. The activities and analysis that you can learn with Power BI generally flow from a common flow. It'll look like bringing data into Power BI Desktop and creating a report, publishing Power BI Service, where you can create new visualizations or build dashboards, share those dashboards with others, and view and interact through the mobile app. So again, depending on how you're going to use it, you could tweak it to the best advantage for yourself. The building blocks to this thing start with visualization, or the visual representation of data like a chart, a map, or other things that will make sense to represent the data in a visual form. They can be simple or they can be complex. Of course, it's going to need some data in order to turn visual. It can be a combination of sources from something like this Excel sheet to other stuff. It can connect with a SQL server. They can connect with a service like Facebook, Salesforce, MailChimp as well. You can create reports, the collection of visualizations that appear together on one or more pages. Great for things like sales presentations, school assignments, all that kind of stuff where you need to put a report together. Dashboards are the way that you can share reports. They're a collection of visuals from a single page that you can share with others. This is a tile, a single visualization on a dashboard. So this little guy highlighted in red is a single tile. The whole thing would be a report or a whole dashboard, and this is the tile. You can arrange them as needed, moving their height or their width. Anybody who's viewing or consuming can see it. They can interact with it. but they can't do things like edit where things are coming from or edit the size. According to Microsoft, it is supposed to be very easy to connect data. And here's how they explain how it's done. Once you have an account with Power BI, you would click on the Get Data in the lower left corner. The canvas is, and that's the center area, will show you the available sources that you can use. Again, all kinds of different places to get data from can be pulled in here. You can do software services as well. These are already made and pre-arranged for you. Each one of these is called an app. In this example, they'll connect to GitHub to request your information. It'll install the app, and when it's loaded, it'll show you information pre-built together about a specific repo. In addition to the dashboard, the report will be automatically generated as part of the GitHub app, and you can use it to create dashboards from that data set. You can select any visuals and interact with them. And as you do, the others will respond as well. You can update manually or select the schedule in order to update the dashboard and everything else that goes with it. You'll have a setting, and again, you can define when you want it to update in order to keep your reports and dashboards all up to date. Any questions? Okay, hearing none. I'm pulling up Canvas right now. So with that, we have completed the 4 parts. So that means another skill submission. If you haven't done the first one already, definitely jump on that. And all the work that came in that, like all the part submission that shows you went through it. You did all the knowledge checks and any exercises. The same will apply for this one. And the same thing applies for the skill submission. You'll meet with me, talk to me about what you want to do. If you are adding on from the last thing you did, that's great. You'll just, those meetings are really fast. They're not 30 minutes. They're at most 10. So it's like, it's like a 10-minute meeting with me where you say, hey, this is what I'm going to add on. This is what I'm going to do from the stuff I learned. Here are some of the reference points that I'll be using. I'll give you the okay. Then you make the video, and then you'll submit the link. Right now I have it here, nothing, but this is not the Cabrillo canvas. In the Cabrillo canvas, you'll see a place to submit your video link, and that'll be that. Just like with the AZ900, if you take the test and pass the exam, then you don't have to do any of this for this module. I will give you full credit for this entire module. So if you take and pass the DP900, automatic A for this module. If you take and pass the AZ900, automatic A for that module. If you do the AZ104, same thing. If you happen to be able to knock out all 3, well, you get an A for 3 modules, and you can jump to module 4, where it's your choice of what cert to do. Any questions? Don't all jump up at once now. Okay, well, seeing no questions in either Discord, in YouTube, or in Zoom, I will end the stream and the recording.